I am going to talk about the fixing methodology of DGU, and then we will go into the details of every seal. So, this is why I am quickly taking you through, is to give you a feel that how you fix a DGU also imparts or conducts temperature like a climate like ours, which is hot outside. So, you have a thermal conductivity which happens when you have systems which are dry fixed in comparison to the structurally glazed facades. So, you have an EPDM gasket system, and this is a pressure plate which is being used, and you also have a thermal isolator, and then this system is fixed like a dry. You do not use a silicon, you use gaskets to completely fix this. So, you need to maintain an interior temperature of 21 degrees. Generally the aluminum frame is of this size, and there is a DGU used, and the DGU has got 6 mm glass, 12 mm airspace, desiccant primary seal and secondary seal. Okay. This system is called as a dry glaze system. Now, we will see what happens when you subject it to the atmospheric conditions, and before that I will also take you through the other system called as silicon structural glazing curtain wall system. Okay. If you see here, there is a silicon secondary seal and a desiccant system, okay, aluminum spacer. Here what we are looking at is structural silicon glazing curtain wall, okay, and we are also talking about a system wherein you do not have a mechanical capping from outside, there is no conductivity which happens because of that, and you have a glass structurally bonded to this aluminum using a silicon sealant, and there is a weather seal. So, this is thermally completely isolated. So, you do not have any connection which happens here. Okay. So, the joint dimensions are mentioned, this is a bite and this is the glue line thickness, and here it is secondary seal is here, okay, inside the DGU. And also there is a Baker rod applied for the weather seals. So, there are 3 different silicon which has been used, or the sealant has been used to hold this unit together, same amount of aluminum frame. And what we are talking about here is also a different desiccated silicon foam spacers, which is called as thermal spacers. Okay. What happens for the temperature evolution for SSG system at 50 degrees? Imagine there is a 50 degree centigrade and you have a high performance glass with a silicon spacer, and you have a high performance glass with aluminum spacer. Here we are talking about a difference with the same way of doing the system, and then see the temperature difference. So, what you have here is, when you have a temperature evolution at 50 degrees, you get 29.8 degrees when you use a thermal silicon foam spacer compared to the aluminum spacer, which is 34. So, there is a difference of almost 5 degrees here, 4.5 4.5 degrees difference, where the temperature becomes warmer compared to the using a silicon foam spacers. So, here it is a clear glass comparison. So, here it is 31.4, because there is a clear glass, there is no coating, naturally the temperature is going to go up, and with aluminum spacer you get 35.4, which is around 4 degrees difference. So, what it essentially shows is, just by using a foam spacer from a silicon foam spacer, you can also reduce the temperature, what is the conductivity, what happens through the system. Okay. So, this is essentially talks about just by doing a difference of silicon spacer to high performance glass, clear glass. So, there is always a difference of 1.6, and within these two 4 degrees and 4.5 degrees. And a dry system versus wet, we saw the dry system, we are going to see the wet system, which is a silicon glazing versus the gasket fixing. On the dry system, if you really look at, so the temperature gets to 40 degrees because of the conductivity which happens because of the pressure and capping system with the silicon spacer, and if you use an aluminum spacer it becomes 42. So, the difference of 2 degrees is noticed by changing the spacer, and where you use a clear glass instead of high performance glass, this difference again becomes 1.7 degrees, but the temperature essentially becomes more because there is no high performance coating glass used here. So, essentially what it talks about is, just by doing a proper selection of the spacer as well as the way it is bonded to the structure, you get very good temperature reduction, and silicon structural glazing again gives you the best possible thermal reduction. There is a way of doing the bonding applications. So, some of the things what we saw, that is the same thing put here. So, this also talks about the U value. If you have a silicon spacer and an aluminum spacer, then what is the reduction of the U value, or how it becomes really good to have a lower U value, because you get 1.8 versus 2.101 when you do a aluminum spacer versus a silicon spacer. Okay. So, what we are talking essentially is, you get a good durability, you give it gives better U values than dry. So, structurally glazed systems give you better U values, okay, than a dry fix system. So, SSG gives lower internal temperatures than dry in all combinations. You use any combinations of dry fixing and do structural bonding, naturally you save. Silicon spacer provides a better U value than the conventional aluminum spacers. So, the key note here is, if you remember, we saw the keynote on the first thing about sealants and the essential way of doing things on seal applications. Now, we are talking about the keynote here is butyl is really the key component against fogging of the IG unit. Any stress on to the butyl and there is a failure, that can lead to IG failure. Loss of adhesion in the secondary seal will do stress on butyl. Only silicon have the best long term performance. So, now we will come to the application part. So, we saw the chemistry part, we saw the different testings and experiment part, we also saw how a combined system of primary and secondary seal gives with silicon and the PAB gives the best durability. We also saw the ways of fixing the DGU with the dry and the wet glazing, and we also saw the effect of that to the U value, and what we also saw is by choosing the right coating how the U value can be reduced and also the solar heat gain can be reduced. So, these are all essential part of DGU, but while coming to manufacturing of DGU, the application is very critical. So, how you do it is, take a prepared glass, clean, if it needs an edge deletion, delete it properly using the proper gauge grinders or the way mechanism suggested by the manufacturer, attach a spacer. So, before attaching the spacer, you need to attach the spacer and make it to the size of the glass, and then clean the spacer, fill the desiccant, apply enough of the PAB around the perimeter of the spacer, press the glass, press the spacer, press the glass and apply the secondary seal, either by manual or by robotic. Okay. But there is much more than what this behind this IG units. So, what is the top 3 reasons for IG unit failure? The top 3 reasons for IG unit failure is workmanship and workmanship. Okay. So, it is very important. You can design, you can choose the right product, but if you do not apply or the workmanship is not good, you will essentially end up with a very bad quality of a DGU. Okay. Any IG production, regardless of the secondary sealant type, it should follow a high quality production process. So, what are the things which are going to influence the performance of DGU? So, the spacer. So, the spacer is a very critical component here again. So, if you look at the spacer, the type of spacer used, how you join them, how you fill the silicon desiccant into the spacer, they are all very critical. I have a slide to run through the spacer which I will take you through. PAB application. So, how you apply the PAB? So, this is a very small amount of primary seal applied on the butyl spacer. So, and there are standards which talks about what is the minimum grams per running meter you should have, which is approximately around 3 grams per running meter you should get minimum, and then there is a width and the thickness which is specified. It talks about say 4, or you have to fill that complete band which is good for a long term durability, and also the thickness of say 0.3 or 0.4. So, which is it talks about 2.7 or 3 grams per running meters per side. So, you have to apply it accordingly. Pressing of the paints, the glass paint should be properly pressed, so they are coming in a good contact with the primary seal and the spacer properly, then apply the secondary seal. Okay. The one more thing which is also essentially important is, before applying the secondary seal, we should ensure that the spacer is cleaned. Okay. So, the spacer cleaning is very important to get good bonding of silicon to the glass edge as well as to the spacer. Transportation is key. We need to transport only when the the sealant is cured completely, and if you do a transportation before that, there are a lot of stress which will come on to the sealant due to the vibration which happens during the transportation, and that can impart or that can affect the adhesion of sealant to the substrates, and what you will essentially have is a gasket or not a bonded material. Okay. And also when it has been essentially installed, it is also important for us to understand. So, how it has been installed, what type of a material which is coming in contact with the secondary seal of the DGU, and how much is a depth, and how it is going to be perimeter filled with. So, those things are also important to understand. So, I will quickly take you through some of that. So, the thermal stress induces shear. Okay, we are talking about the spacer, which is an important thing and have a longevity of Ig unit. So, there are different types of spacers you can have. So, thermal stresses actually, because it is a metal, it is going to conduct heat. So, there is going to be a differential movement between spacer and glass as well. Okay. So, essentially there is going to be some movement when it happens. So, there could be a failure in the primary seal. So, the stainless steel has got 10.2 to 11.4 millimeter per meter per degree centigrade 10 raised to minus 6. Aluminum has highest and glass is 8. So, if you see the combination, when you do glass and aluminum, there is a differential movement which happens because of this values, okay, 23.8 versus 8, and whereas these two are close. Okay. So, stainless steel spacers and glass, the differential movement is lower. So, this is a simulation done on a finite element analysis on a lower room temperature and a higher temperature when an aluminum spacer is subjected to. You can say here at lower temperatures like minus 30, this gets shrunk, it becomes shrink, and this is the normal temperature, and this is stimulation. Okay, this is slightly made it big, but this is what essentially happens when it becomes plus 60 degrees centigrade, it expands. Okay, so you can see the change of behavior on the corner. So, at low temperature it is pulled inwards, at high temperature it is pushed outwards. So, its bending angle is this is greater than 90, this is less than 90. So, this is what happens with aluminum. You can see this galvanized steel is better, stainless steel is the best. So, same thing on the lower temperature, aluminum, galvanized steel and stainless steel. Okay. But essentially in India we use mostly aluminum. Okay. But you can also look at other materials like stainless steel, which can give you a much more better DGU long term performance. And also the spacer frame corner assembly and joint filling. Okay. Essentially we apply primary seal along this edge, and this has to be completely nicely filled with primary seal, and then this helps to bond the spacer to the glass, and also there should not be any air gap or leakage. So, this should be nicely fully filled in. So, spacers are able to accommodate part of the movement of the IGU, like warm edge spacers if you have, they do not have much of a differential movement because they are not metal essentially. And also if you are doing a bending or we are doing connecting of the spacers, so no gap should be there, okay, or steps should be there. So, corner keys again they need attention with PAB, any joint area should be completely sealed with a primary seal to avoid any moisture penetration. If you are doing a butt joint, do it on the longer edge, middle of the joint, long edge rather than on the short edge. So, because when they are subjected to stress, the short edge gets differential load, so you may have more stresses on that. Speed of bending, how you bend the spacer, sometimes you do it fast, it may lead into micro cracks, and then essentially the breakage of the spacer when it is in use, and then essentially the failure of the DGU. Also any joints you fill it with PAB, enough desiccant, okay, also to be filled inside the spacer area to avoid keep the air dry which is inside the DGU, or since there is some moisture penetration, again the desiccant helps to absorb them. Primary seal, we are coming to the second one, the primary seal which is already glowing. So, this is a very important seal for DGU to give long term durability against fogging. So, it has to have a good heat and UV stability, it should have good adhesion to the glass and the spacer, should be low sensitivity against water, and the lower viscosity PAB. So, better results in initial testing, but it do not perform in long run. So, if you have a material PAB of lower viscosity, maybe it is easy to apply, but it will have a tendency to run down with time. So, directly to sunlight or roof glazing or structural glazing. Okay. So, and also on the equipment side, maintain the clean applications. When you see some of the PAB application machines, they are all having the the cured material on the belt or on the edges. So, it will not allow a good uniform application of PAB. Extrusion pressure and temperature is critical. So, maintain the temperature so it nicely comes out, and then keep the pressure so that it touches and nicely fills that. Monitor application speed, do not run it so fast that you are unable to fill it properly and not to be pulled as a string. Okay, it should it should wet out the spacer, it should not be like a line. So, these are some of the guidelines. Greater than 4 millimeter of this width and 0.3 is essential. 3 grams per running meter is the weight of the PAB to be applied, and also avoid skips. There should not be any areas where there is no primary seal, and good surface wetting and flow during glass pressing. So, it should be nicely wet, and 0.3 mm thickness and greater than 4 mm. So, this is very essential things for the primary seal. You can visually see, you can control it. So, these are nothing like you cannot see them, okay, when application you can see. So, second is pressing. Once you make the clean glass and applied PAB and then you press it, okay, you press the spacer to the glass and the PAB is viscoelastic. So, it flows under low shear rate, behaves elastic under high shear rate. So, if you pull it fast, it will behave like a elastic, but if you pull it slow, it will come out, okay. Temperature. So, again the colder the more elastic and the hotter the better it flows, okay. So, what is important to understand is when you are doing the application in the lower temperature or you have a controlled atmosphere where you do not know to monitor all this, if you have a winter or a summer, then this will affect the application of the PAB. And also the monitor pressing, it has to be properly aligned so that you get a uniform gap around the perimeter and then press the other pane on the spacer. So, secondary sealant. So, the minimum is 6 millimeter which has to be applied. This is the one which is secondary sealant silicon here. It should be high modulus and also for structural edge this is minimum 6, low volume increase under high humidity. So, you have to select a product which now is always silicon. So, you have to always silicon for the secondary seal and also as a combination they give the best durability, okay. So, we are going to see again we have seen that just to bring it back, with silicon you get the lower temperature dependability, better mechanical properties for the long term, very low water pickup, it is actually a water resistant material and best UV resistance. So, you get long term durability, okay. So, what are the essential things for the DGU? When you receive the material, you always look at the batch numbers and you always look at the shelf life, okay, the expiry. So, you have to have the material with minimum shelf life of say 2 to 3 months when you are actually starting to use the material, and then essentially there is a condition which is mentioned as a storage temperatures. Always store this material under 30 degrees centigrade for both part A and part B, and if it is not in use on a machine, if you are going to keep it for the longer time, you can remove and pack it airtight and then keep it in the stores, okay. So, the tests which are to be taken you have to conduct while applying the secondary seal is the butterfly test. So, you are mixing two components A and B. So, the A and B have to have uniform mixing, there is a black and white component. So, when you mix it, it should not have streaks of white or dark blacks. So, you should not have that, you should have an uniform color mix. Snap time is to check the ratio between A and B. So, there are recommended ratios from the manufacturers which are generally 11:1 to 13:1 by weight. So, you can always be in the range of 12:1 by weight, okay. Adhesion, you have to check adhesion of secondary seal to glass as well as the spacer. So, there are certain tests like peel test, glass butterfly adhesion test and H bar which has to be you have to conduct as part of the QA program. So, this is a picture showing you the test of the butterfly. So, once the machine is started, you put the pail, remove the air and then start applying the mixed silicon on a paper and fold it and open it. What you get is a uniform color mix, okay. So, you do not see any streaks here. So, that means this is a good quality sealant which can be used for the application. So, if you do not have a good quality, this is a bad quality which is rejected, or even if you have some streaks, that is rejected. So, what you need is this. And second test is to check the ratio. You take a small amount of mixed silicon in a cup, put a spatula. When you initially pull it, you will find a string. After some time, this will snap. The most of the times for many products, the snap time is between 35 to 45 minutes. So, this can be slightly affected because of the climatic conditions, but if anything in this range is really good, okay. The peel adhesion test, HPs, butterfly adhesion test. These are again very important quality control check we have to do prior while we are doing the application of silicon onto the DGU. Okay. So, you have a glass spacer, you apply a small amount of silicon onto the spacer by cleaning it and pull it. Same thing you do it on the glass, apply a small amount of silicon, allow that to cure after 24 hours, pull it. So, when you pull it, the silicon should not leave the substrate and come out clean. Okay. And H piece is something like you make a joint or like a H. Okay. You take 2 panes of glass and then apply a silicon in the middle and allow it to cure and pull this using a tensile testing machine, and you can see the failure should happen here, not either on the bonding area. Okay. The butterfly adhesion is a very normal test. You take a glass, 2 panes of glass, put a spacer around and then apply silicon on only one side. After 24 hours you open it like a book. Okay. Essentially you will see that how the silicon is bonding to both glasses and the spacer. Okay. So, this is a picture showing the peel adhesion test. You can do it on, you have to do it on the glass, you have to do it on the spacer. After 24 hours you just pull it, and what is essential is it should not leave the substrate and come out clean. This is called as good adhesion. Okay. This is the butterfly adhesion. You take this 1 feet by 1 feet glass, put spacer around, either way you can do it. You put a secondary sealant here on one side or put a secondary sealant on this side and then open it like a book. Okay. When you pull it, and you can see that the adhesion of silicon to spacer and to the glass, it should not come out clean from both substrates. You should fill all primary and secondary seal throughout the perimeter of the DGU. There should not be any gaps. Okay. There should not be any voids, and the bend, there should not be any discontinuity. It should be a continuous application like this. Okay. And here full, and the misaligned spacer, if the spacer is misaligned, you are going to have differential secondary seal bite, which is not good for taking the loads. Okay. Then you have to pack them properly, allow them to first cure. You have to have a curing of 24 hours for 2 component, and depending upon the bite size 7 days for 1 component. Okay. For a 6 millimeter bite, generally you would need 6 to 7 days to cure for if it is a 1 component. But most of you do not use 1 component, you all use 2 components. So, the recommendation is to keep it for a day. Okay. And then pack it nicely, you do not allow them to have differential loads between 2 panes. Even while stacking, if you are stacking vertically, ensure that both the glasses are supported properly and there is no differential load coming on the sealant when it is in uncured stage. And avoid height pressure differences. Okay. So, if you are doing an application on the ground level, sea level, and then exporting it to a very high altitude, when you are doing that, you have to have breather tubes or capillary tubes to untie them, and then so there is no pressure difference which will cause a concave or a convex shape in the DGU. Okay. So, this is something which you need to understand depending upon the insulation sites height. So, to summarize, what is important to make a high quality IG unit? Glass, you need to have a smooth glass surface, no rough surfaces, no coarse coatings. So, ensure that you have a good wetting of silicon on both primary and secondary seal, and also remove the whatever the high performance glass coatings which needs to be removed properly, you remove that, and also you check with the manufacturer on how much it has to be removed. Clean and wash the glass panels properly, use the proper water quality to clean them. Spacer, set it properly, bend the frame, have that constant width around, and position them properly, apply butyl with a smooth butyl for the required width and the thickness, fill enough desiccant, and it should be fresh. The desiccant also should be tested for its temperature rise as well as the moisture absorption. Clean and prime the spacer if it is required. Some of the spacers would need some cleaning and priming. So, on the butylization, maintain the machine. These are essential things. We talked about 3 grams per running meter, greater than 4 millimeter of width and 0.3 millimeter thickness. So, these are all important for you to give you a good tight primary seal. Connectors also properly butylized, and if there are any holes which are gas filled, that has to be also plugged properly. And also frame setting, you have to set the frame properly so that you have constant edge throughout the perimeter. You see visually, and then if you see any breakages, redo it. Pressing, inline pressing, you can do the inline pressing, you can do an inline gas filling, it should be smooth and easy, should not be very rough, and also it should not so much compress the material like a primary seal to come inside the DGU. And again so when you press, you get that homogeneity around the perimeter, not too much of a thick and thin butyl. Okay. No overpressure or blown up allowed after pressing. Secondary seal, which is again silicon sealants. Silicon sealant is ultra high modulus you have to use, which has got a good elastic recovery at all temperatures. So products are like 3362 or 982 is from what is generally used. Automatic, immediately you can do an automatic application, or you can do a manual application around the perimeter. Check the mixing, check the butterfly test, check snap time, do peel adhesion test, and also design the secondary seal depending upon the loads which is coming on to that. 6 millimeter is minimum. Generally we do not recommend 4 for any of our commercial glazing applications. So what you need to do is, whatever tests you do, you document them, you maintain records for a glass test, which is like either you do the butterfly on the glass or you can do it on the paper. Snap time test. Mixing ratio is for the pump, to check the quality of the pump. Delivery of material, so this is done randomly, so you do not need to do it every time, but it is required as a diagnostic test. You can do it once in a month. Peel adhesion test, which is very essential on glass as well as on the spacer. You can do HPs or peel adhesion. Butterfly adhesion is another way of doing the HPs test. Okay, you can do this, and this you can do it intermittently. Okay. Application equipment, you need to have a good dispenser from a reputed manufacturer who gives you service, or you can have your own service engineers maintaining this equipment and checking the edge seal, checking the air pressure, indicators, the valves, and cleaning the hose, the mixer properly, so that you do not have time to time breakdowns. So, this is an interesting case I wanted to show it, which is available in Cardinal. When the Cardinal started making their DGU in 1976 with aluminum spacer, PAB and polysulfide, they started with polysulfide. They had a failure rate of up to say 8%, when the life of the DGU was moving from 0 to 20 years. Okay, they give 20 year essentially, because their process is so nicely managed, they are able to give a service life of 20 years for the DGU. Then in 1978 they changed to silicon, and you can see that it immediately dropped from 8%, what you see here, to just less than 2%, okay, even less than 2%, 1.5. So this was one of the significant thing they got it, and when they moved to stainless steel PAB silicon, which is their own proprietary design, it got further lower down to 0.5 or even lower than that. So what does it show is, choosing the material combination and also doing a good quality control in the whole exercise, you can reduce the defect what happens on the DGU for a 20-year life. Okay, you can see that. So as per them, what they do is, these are the important things they always talk about, is get everyone involved in the process of making a good DGU. Do regular quality checks, maintain records properly, understand the products, understand the behavior, use proper safety PPEs while using the materials, store the material properly, apply them in a good atmosphere, and also purge the sealant periodically so that you do not get the cured ones, perform regular pump maintenance, edge delete coated glass as per the manufacturer's recommendation, understand the total quality control application procedures. Okay. Things to avoid: do not lubricate around IG sealant, especially non-silicon based, silicon based sealants which are like different cure, I will show you this, and also the non-silicon based. Stack uncured IG units at an angle. Okay. So you have to properly keep them at an angle so that they do not have impart loads. Skimp on sealant application, how you finish it, do not scoop them out. Glaze, do not glaze, do not stack them on an angle, you have to stack them vertically, both the pans should be supported. So you do not use anything like lubricants around the IG sealants, you do not skimp on the sealant, okay, while application. You do not glaze or ship them before it is cured, do not use smoke heat around the area where you manufacture, do not use lotions, cream, do not use expired materials, do not allow gaps or do not drag spacer, across the floor. So, this is something which they essentially say that do not do it. So, just to quickly take you through the standards, the standard is there are two standards which talks about the long term testing of DGU, EN 1279 and ASTM. So, in 1279 what they talk about is doing the climatic test at 12 hours between a temperature of -18 to 53 for 4 weeks and 7 weeks at constant temperature with 95% RH. So, there is a temperature change, they do it for 4 weeks from minus to plus, and at a constant temperature they do it at a high humidity and check the durability of the DGU in EN. Whereas, the ASTM E2188 talks about durability in high humidity 60 degrees centigrade at 95% for 2 weeks, but they put this into weathering. They ask you to put it in UV chamber where it is subjected to the actual weathering conditions with temperature variation, water mist and UV for 9 weeks, and again the high humidity for 4 weeks. So, what is important here is a climate like ours, the UV is a very essential part. Though EN is a very good standard, though it does not cover anything on UV. Okay. So, what is essential is we need to adopt to the standards which also has a test methods closer to ours. Okay. So, the ASTM seems to be closer. So, this is an UV chamber wherein they put the DGU tested for 9 weeks. So, why am I talking about this is if you look at a country like India, we have lot of zones and areas where we have UVs. Okay. It is not that we do not have UVs. So, we have UV, so UV is very important. It is the same thing in US, you will have UV around, but if you look at Europe, they do not have much of UV. Okay. For them it is not an essential thing, whereas for us this is very important. This is available in Google, you can Google it out and check this. Last, I am going to just summarize. So, only silicon dual seal insulating glass units are approved by the industry for use in glazing applications. We cannot have a organic seal put on a commercial glazing where you have a degradation of the secondary seal which happens. Okay. Silicon seal attaches the exterior light of the light to the interior and also the unit to the building. Structural glazing, the edge is visible. The roof glazing and skylights, again you can do it with completely silicon. You can use in the commercial glazing different types of glasses, and all of them are subjected to temperatures depending upon the climatic conditions what you see here. Okay. Dry gaskets, excessive pressure exerted while fixing the dry system on the primary and secondary seals can squeeze out also PAB. Just be careful about when you are using a dry system, ensure that the pressure is normally maintained properly. And also what is also important is when you are using the DGU which are made with the neutral cure alkoxy systems, do not use any acetoxicure silicons in contact with the secondary seal of the DGU, or do not use this as a sealant for making the DGU. Do not use anything with EPDM with sulfur, because this can attack the coating of the glass as well as the secondary seal. Do not use any bitumen based sealant in contact with the DGU secondary seals. Do not use any solvents, okay, which will migrate through the silicon. As I told you there are some moisture vapor permission rate silicon can allow, and it can also cause the PAB thinning. Do not use any solvent based water repellents around the perimeter of the DGU. So, also the incompatible setting blocks, like if you use a EPDM with lot of plasticizers or the sulfur in it, it can cause a color change and make it incompatible. So, you can see them here. So, these are all the essentially the effect of the setting block not being compatible with the secondary seal of the DGU. And these are the PABs affected by the solvent. Somebody has put a high chemical around the perimeter while cleaning the, or while applying that in a wooden frame or something. So, you can see the primary seal running down around the perimeters here. Okay. Here again a wrong sealant has been used which is coming in contact with the PAB. So, last, what is important is you have structural silicon holding the glass, the entire DGU to the frame. You have secondary seal inside the DGU which is holding two panes of glasses together. You have weather seals. They are subjected to wind loads, they are subjected to UV, they are subjected to sometimes dead load, and they are also subjected to differential thermal movement. Silicon provides a good flexible anchor for the long term. So, that is the right choice of the material, but what you need to understand is you need to really understand that there are many parameters which are involved while making the DGU. Okay. So, this is what I had today to share it with you. Now, there are a lot of new trends coming in, people are coming with cold bend glasses in DGU. These are all new approaches, there are a lot of stresses which will happen on the secondary seal. So, essentially we need to evolve with an industry, keeping in mind that what essentially we need is a very clear DGU at the end of the day, which has a good long term durability. These are some of the standards which you can refer, and this will give you a lot of ideas about the tests which needs to be involved while making the good DGU. Okay. So, last but not the least, the concept is clear, we do not want the DGU to be fogging like this, okay, and we saw what needs to be done to get to that.